Perfect. Awesome. We can hear you and see you.
Thank you so much. So I will give you a brief update on Chiplet Design Exchange. And this is a group effort. Group is primarily, work stream is primarily organized by myself and David Rochkoff from 3 Systems. So in the big scheme of things, we fit in the reference flow, which is comprises of packaging panel and user panel and some other talks that you have heard today. So Chiplet Design Exchange is a well-participated group from folks that represent designers, architects, electrical engineers, as well as the assembly manufacturers and EDA vendors. And we primarily work around the workflows. During last year or so, we have done some pretty interesting work that we presented at Design Automation Conference this year at Valley ML. Some of the notable presentations that were made in Chiplet Design Exchange are primarily related to workflows and EDA flows by notable companies and folks who contribute. Our charter overall is to come up with machine readable description formats that are around chiplet mechanical, power, electrical descriptions, as well as developing workflows for behavioral, electrical, and thermal modeling of systems. And we also have an activity on package POC conversion. So at a very high level, if you have been listening to all the ODSA talks, we focus primarily on electrical and mechanical aspects of the design. And we are below the architecture stack, and we think quite a bit about the signal integrity, power integrity, thermal modeling, power modeling, and those aspects of building these systems. So just to give you a flavor of what kind of activity we are working on, so by the end of this year, we are targeted to write a white paper that primarily focuses on chiplet architecture and early design. And the idea is that this white paper will be a tool for architects to do some early studies and feasibility for a project, primarily for electrical, mechanical, and other related issues at the early stage. And when we go into package POC, we'll be focused a little bit more on workflows by using an example to do a deep dive, and we will share that learning with the industry. So just to give you a highlight of different contributions of what different companies have made. So ZGlue opened up a test case, which is a chiplet-based design called OmniChip, and shared with a bunch of companies that did various other studies on this design. And collaboration was done by ANSYS, Mentor, MACOM, SI2, 3 System. And I'll just give you an overview of some of the outcome of it. So this particular work was done for chiplet thermal modeling, and we started with the test case, and we went through power simulations, we went through thermal simulations, and the work was done by different companies. So data was being handed over with commonly understood formats or formats that we have been exploring in the work group. So for example, 3 System, they did power simulation of the test case, and they have a tool called Power Meter. So we provided them data, and they used unified power model and data sheets and Liberty formats. And they demonstrated that power simulations can be quite effectively done with their tool. This was also shared with SI2, they used a different flow called unified power model. And they came up with the simulation of the system. And what you can see here is on x-axis, the different vectors being pushed through this chiplet-based system. And on y-axis, you see the power dissipation, but different chiplets are in different modes of operation, and colors match, and you can see that microcontrollers in this particular case is the one that is burning the most amount of power. So a couple of companies have worked on this workflow on how to take the data sheets and description of scenarios and simulate power with it. And then we did some very interesting work where we did thermal modeling of it, and thermal data exchange format that the group has really liked so far and has explored is EC XML, electronic cooling XML format. Actually was recently also published by JEDEC. So it actually worked out quite nicely across various companies in terms of defining the geometries and heat sources, as well as fans and the cooling of the whole system. So we will be writing a little bit more about our experience and using this test case and sharing with folks what we have learned. So at a very high level, we really want more participation. We have one very important topic which we think will benefit the whole industry quite a bit, where we see a gap, and that is for chiplet behavioral modeling. So if anybody out there is interested in system description, this will be a very nice addition to the team. We are also looking for volunteers for power integrity, signal integrity workflows. So that will be one of our main targets in the next couple of quarters, to develop workflows on those. On power and thermal side of things, we have made some progress, and but we overall are looking for volunteer help on the proof of concept on various workflows, as well as the package POC. We also ask the industry to please list your chiplets with us and share your requirements and your wish list for chiplet modeling. So this will be a great help and a great opportunity for you to showcase what you have and get some collective feedback. We are really excited about the Chiplet Design Exchange. You can get in touch with myself or David Rachkoff, or you're welcome to go through the ODSA wiki. Our contact information is listed there. We meet every week on Tuesday at 1:30 p.m. We often skip some meetings here and there, but we're pretty regular. So if you can participate or you are interested, we would love to hear from you. Thank you so much.